And these videos are best played at 1.25 speed on YouTube, and Google tends to slow down my voice for whatever reason. So, hey, listen, I hope everyone's doing okay. I hope the pace that I'm going at is working for you. I ultimately like to go faster with you guys, but I was directed by the principal to only give you a max of 2 hours of work. So, with all the reading and stuff you have to do and the videos you have to listen to, we've got to, cut it down a bit. So, anyhow, let's get started with the second part of electrostatic charges and forces. So here you go. You've got now what we know of as electrons. Okay, we're going to call this electrons, and there's also something called protons we've looked at a little bit in the last video. Now, the cool thing about these two things is that well, a little facts on the electron. I'm going to say it's very tiny. Now, protons are very tiny too, but protons are about 1,600 times bigger. 1,600 times bigger than the electron. So, hey, listen, so tell me something. If something's 1,600 times bigger than something else, which is the one that's going to do all the moving? Yeah, you got it. The electron. Okay, so the electron does all the moving. Now, not all the moving, but I'd say a good majority of the moving. So when we have electric currents and such, we're going to be talking about how the electron is the one that's doing the moving. Now, these two are equal and opposite charges, and what I'm going to do is I'm going to give you guys some new terminology next time about how to measure these charges. So, and again, there's a lot of demonstrations that you guys are missing, unfortunately, and one of them does include the Van de Graaff generator, which is a very, very good a visual approach to the whole thing. But let me try my best, and hopefully you guys are going to do your best in the work. Okay, I'm going to give you guys a situation where we're going to be looking at spheres. Okay, here's a sphere. And so this sphere is a metal surface sphere. Okay, this here is something we're going to call an insulator. Okay, this sphere is set up on a table so that this right here, the piece that's holding up, is made of something that is an insulative material, such as a plastic or an acrylic. Okay, so that means that if I put a charge on this, the charge is not going to go into the ground here. And we'll talk about what the ground is a little bit later. All right, so let's set up the first experiment. So I got myself a sphere. Okay, what I'm going to do is I'm going to give it a charge. So what I'm going to do is we'll say there are two positive charges and there are, let's say, 4 negative charges on there. Okay, just for sake of ease here, let's just say that there are 1, 2, 3, 4, 1, 2. So let's look at what the net charge is on this whole thing. Well, this cancels with this cancels with this. I'm left with 2 negative charges. So the net charge on here, and we're gonna use a terminology for charge as a Q. So the net charge in this whole deal is going to be -2, and we'll just call it -2 electrons. So Q is a term for charge, is equivalent to -2 electrons. That's the charge of this thing. Okay, so that's how we write that out. Now let's say I were to have another sphere here. Okay, and forgive my artwork. Okay, it's not the greatest. I'm going to say that we have some situation like this. Okay, we have this sphere. Okay, look at a negative cancels with the positive, a negative cancels with the positive, and the Q is equivalent to positive. And we actually use the E. Yes, we still use the E, even though it's more protons. Now, this is considered to be a positively charged rod. Now, none of the charges are escaping to the ground because, again, this is an insulator. This doesn't let it go to the ground. So the Van de Graaff generator, what we do is we spray. We actually do. We actually spray electrons onto the surface of this by a mechanism that takes electrons from a belt, a rubber belt, and it puts the electrons onto the surface of this thing. Okay, we're not going to get into the details, although if I were in front of you, I'd show you how it works. Let's just say this. We know that we can spray electrons onto this surface. Okay, now, so this is positive, this is negative. Okay, so I'm gonna stop there. Again, the video is gonna go about 10 minutes, but I'm gonna give you guys some actual scenarios. Okay, here we go. Okay, so let's look at a scenario here. Okay, so I'm gonna just we'll take our sphere. Okay, and let's call it a neutral sphere. So let's say I've got particles. Excuse me. If I got particles, electrons, and then protons on the sphere. Now, one thing we can say about this one is that it's neutrally charged. There's an equal number of both. Okay, that makes sense. Okay, so let's say I were to take a rod. We'll call this a metal rod. And let's say this metal rod is very much negatively charged. Now, if I put this rod close to this sphere, and you want to be listening at this point, if I take this rod and put it close to this sphere, the electrons in this rod, since there are much more of them, they are going to make these electrons in this sphere flee. Okay, let's see what happens. What happens is, look, the electrons on this side are causing the electrons over here to flee as far over to the left-hand side of this diagram. So look what happens. The positives are on the right, the negatives are on the left. Okay, the term for this is called I spelt it wrong. Polarization. That's when one type of one thing goes to one side and one type of one thing goes to another side. Kind of like politics, where you have the Democrats on one side and the Republicans on the other side. This can be looked at as polarization. Now, the cool thing was that before these two things got in contact with each other, there was no attraction. But now look, negative electrons are now attracted to positive protons. So now there is an attractive force felt between these two things. Okay, they're attracted to each other. Now, we've done nothing to the number of charges. All we've done is we rearranged the charges. That's what happens when we polarize something. Okay, I'll give you guys a chance to write this down in your notebooks. Pretty important term of polarization. Okay, now you know what polarization is. Very quickly, I'm only going to let this go another 2 minutes or so, maybe 1 minute. Two new terms. Okay, we're going to learn a term called conduction and induction. Okay, two new terms. Okay, conduction and induction. Okay, what we're going to be doing is, try to focus that in there, is just writing a quick definition of each, and then we'll move on to the next video. Conduction is charging by touching. Okay, induction is charging by proximity. Okay, so different ways to charge objects. You can touch the object, or you can use this word here. This is I'll even put near. So if you put an object near another object, it's able to charge it that way. So I'm going to stop there for now. You're at about 10 minutes, and we'll talk about the details of these things.